All right, keep going. I want to fill out this whole chart here before we graph. Next one's going to be radical 3 over 2, right? Sine of 60. I should have remembered that from last unit. All right, so radical 3 over 2. The only issue I have with that is that's not going to help me too much because I don't know where radical 3 over 2 is on the y-axis. So just what do I have, 0.87 about, or 0.86? Right, everyone? About point. So I'm just going to leave it as a decimal here because that's going to be easier for us to graph than radical 3 over 2. All right, let's keep going. Keep filling out my chart. What do you have at 90? Well, as you find them, we can just yell them out here. So we got 1. And then I think we start some repetition again. At 2 pi over 3 or 120, we got 0.87 again. 150, 1/2. At 180, 0. 210. Oh, hey kids, why did all of a sudden change the negative? Here we go. See, it's all linking together from last unit. Now we're entering the third quadrant. So yeah, these values should be negative because it's sine. Negative 0.87. I got negative 1. Negative 0.87. 330, negative 1/2. I should end at 0. 360 or 2 pi. Okay, so just make sure our charts match before we plot the points now to graph. Just so everyone knows, we're only going to graph from 0 to 2 pi. I'll talk about what happens in the negative direction when we're done. So all these values are going to get plotted from 0 to 2 pi. First thing before we graph, anytime we graph from now going forward, anytime we graph, your x-axis isn't going 1, 2, 3, 4, 5 anymore. Anytime we're graphing sine and cosine, you graph the x-axis in radians. Okay, the x-axis always gets graphed in radians. It's not 1 unit, 2 units, 3 units. It's all in radians. And you have enough tick marks right now that match the number of spots in your chart. So help me out. First one, at 0, what's the sine value? At 0, what'd you find out? So there's my first point. 0, 0. Now we're going in the positive direction. At pi over 6, it was 1/2. Again, every tick mark represents a radian that we're going here. So pi over 3, 0.87, do your best. All right, do your best. What? It's a little bit below 1, but above 0.5, right? So do your best. And then it hits at 90, 1, and then I'll let you guys go from here. Do not connect them, please. Do not connect them. So keep following your chart. And then after pi, you should be going in the negative direction on the y-axis. Good. Before we connect them. Okay, we ready to connect? At the beginning of class, I said this was a sine curve, not a line or anything else, and that's what we're going to make it now. A curve, a smooth, take a look at the top, curve. Okay, I don't need, it's not the heart monitor at the hospital. We don't need peaks and valleys here. All right, we need nice, smooth curve. All right, I don't need anything looking like this up here. Okay, what you're looking at right now up on the screen here and up on your paper, that is a full sine curve. Okay, this is what a sine curve looks like. This is one full one. So if I asked you to go past 2 pi, you know what would happen? And you don't need to do this. It would start repeating itself. All right, if I went past sine. This right here from 0 to 2 pi, this is what you're looking at is one full sine curve. So what the heck happens in the negative direction? Starts repeating again. Okay, so if you want to real quick, we don't have to, I'm not going to have you graph all the points, but let's see, I have 0, this would be at 0, 0, halfway in between would be down to -1 here, halfway in between here would be up to 1 here. So that's what it would look like on the other side. It would start repeating itself. But that's what one full one looks like from 0 to 2 pi. All right. This is the last time we do this for sine. This takes way too long. Having this huge chart, typing in all the numbers, this takes way too long. So I need you to know a few facts about the sine curve right now that will help us graph immediately now. Where did we start the sine curve? At, okay, here we go. Sine curve starts at 0. Then it traveled up to, anybody got a fancy name for this point right here other than 1? The highest point on the curve? There we go, Ethan. Starts at 0, goes to the max. Goes to maximum. This is going to help you graph every single sine curve we do. So it starts at 0, goes to the maximum. Keep going here with me. Then it went back down to, oh, easy, easy. Before that, I want to hit a pit stop. It went back to 0. So goes to the maximum, back to 0. Then went where? Minimum, right. Goes to the minimum. And then where does it end? Back at 0. All right, so this is the sequence I need you guys to, it'll come naturally. It's nothing you got to memorize. This is the sequence of every sine curve and where it goes. The only thing that's going to change for us today is where's the maximum and where's the minimum. Because here it was 1, it may change. Right? Whoa, I'm not done yet. One more term here. Period of a graph. Okay, period. Everyone remembered what one sine curve would look like, right? A period is how many units on the x-axis it takes to make a full curve before it starts repeating again. How many units, and I don't mean 1, 2, 3, 4, 5, 6, because remember, it doesn't go by that anymore. All right, so how many, the length it took on the x-axis to make a full curve, how long is it from here to here? I can't get down any lower. I have like 2 fake hips here. 2 pi. So we say the period here is 2 pi. How long on the x-axis it takes to make a full curve before it starts repeating. Okay? That's what period is. You're going to hear that word again and again. Any questions about the sine curve? I got to take a break here. Everyone good? Okay, let's try out another one here. But now, somebody tell me what's new here. What's new here? What did I put in front? A number now, right? Now it's y equals 4 sine x. All that 4 does, that's my new min and max. So instead of going to 1 and -1, this is going to go to 4 down to -4. That's what the number in front tells me. All right? How high and how low this is. We're actually going to have a name for it later on this week. All right? But for now, that's your new minimum and your new maximum. And good news, I don't have to do all these darn points anymore. All right, I'm only going to do 5 key values, and that's it. 5 key values, and here they are. Ready? What do you know about sine? Where's the start? I don't care what number's in front. For today, it's going to start at 0. Watch how quickly this is going to get done. Next, if you got to go back, sine starts at 0, then it goes where? Max. And we just said, hey, it's not 1 anymore. It's going to be 4. So now I go to pi over 2. It's at 4. Notice, I don't care about what's in between. I'm only hitting what I'm going to call the key values. And we'll talk about what they are here in a second. So it starts at 0, goes to the max. Now where? Back to 0 at pi. So look, every 90 degrees, I graph one of these key values. Starts at 0, goes to the max, back to 0. Where does it go now? To the minimum, -4. And where does it end?
0.
Back at 0, 2 pi. So I'm going every 90 degrees, I'm graphing one of these key values, a 0 or a min or a max. So one last time here. Starts at 0, goes to the max, back to 0, to the minimum, ends at 0. Smooth curve, everybody, smooth curve. And what would happen if I had you graph past 2 pi again? Here we go again. We're repeating. Okay, it would start repeating again. I've got to review with you a couple things from Algebra 2A last year. Not this, though. What's the period of this one? How long would it take to repeat again? Look on the x-axis. How long? How many units is this? 0 to? Okay, that'll be the answer for a little bit. We'll change it later in the week. All right, range. Those are your what values? Y values. Domain is your x. Range is your y. So you tell me, how high and how low does it go to? 4 to -4. Okay, I'm going to write this a little bit differently than maybe you did last year. I'm going to use brackets. And I'll show you why brackets versus the other type you could have. What's the lowest it goes?
-4.
So that goes first. Your lowest, comma, 4. Anybody remember the other option other than brackets you could have? Well, that or parentheses. What's the difference between this versus if I wrote this? Is -4 actually on the graph? Right here, right? That's why it's got brackets. It's actually on the graph. Versus parentheses, that means it's not. Okay? I'm actually -4 is actually part of the graph. Okay, good. All right, next, I'm going to come around and look at your papers for this one. Where is it increasing? Do you think you could lightly, with your pen or pencil, lightly circle the part of the graphs where you think this is increasing before we write the answer? Lightly circle, so it doesn't interfere with the rest of it. Lightly circle where you think this is increasing. You should have 2 spots, hopefully 2 spots. Hey, ready? Right here. And right here, it's increasing. From right here to here, it's decreasing, right? Everyone all right on where it's increasing before I write my answer? Okay. Now, how do I write these 2 spots? Look on the x-axis. This is from what to what is it increasing on the x? Don't tell me 0 to 1. I'm looking for the x-axis now. Richie, 0 to? Pi over 2. Now watch. Ready? 0, comma, pi over 2. Now we got to talk. What do I put around these? Is it actually increasing at 0 or is it just there? It's just there. So I'm going to put a parenthesis there because it's not actually increasing at 0. Is it actually increasing at pi over 2? No. So it's just parentheses 0 pi over 2. And where else is this bad boy increasing? 3 pi over 2, comma, 2 pi. And same thing, parentheses. It's never actually increasing at those 2 specific points. Everyone all right? And then there's one more question, right? What line splits the min and max values in half? Can you draw that line? It should be a horizontal line on your paper that splits the min and the max in half. Can you draw that line? So you got 4, you got -4. Where's the line directly in the middle there that splits them? Highlighting this line right here, the x-axis. Anybody know the actual equation for that? I don't want to write x-axis.
X equals 0.
That would be
Y equals 0.
y equals 0. One more time with me. Where's sine start?
0.
Every sine curve will start at 0, then go where?
Oh,
To the max, then go
0.
to the 0, then go minimum, finish at 0. Guys, I can't tell you how important it is you know the direction of the sine curve. All right, especially when I start throwing other numbers in there other than one number out in front. Questions on sine, because I got to do cosine too. All right, same thing I need you to do for me as we did at the beginning of the class. Now we're going to do cosine. It's going to look a little different. So now do cosine on your calculator and fill in that chart for me as much as you can. So right away, you notice something different. At 0, where's cosine go?
1.
Yeah, so it will not start at 0 like the sine curve. Got to know the difference between the two here. Go ahead, fill out the rest of the chart for me. Make sure our charts match before you actually hit up graphing the points. Make sure it starts at 1. And go from there. If you're confident, draw in your curve. This is not a V. And what we're looking at, this is a cosine curve. If you went past 2 pi, what would happen again? It's going to start repeating itself. Correct. So to the left, the negative side of the x-axis, it's going to start repeating again. So let's do this quickly. We don't have to graph everything. So halfway in between, it's going to go back to 0. At pi, it'll be at -1. Back to 0, halfway in between, and then end at 1. Okay, so that's what it would look like on the other side. Just start repeating itself again. I want you to do the same thing you did with me for sine. Tell me where it starts, goes, ends. Where does it start?
1.
Ooh, watch it. I want to be a little bit more specific.
Y.
Yes, if this one starts at 1, but 1 is also the what of this curve?
Oh, the max.
The max, right? So cosine will always start at the max. Don't just think 1, it depends on where the max is. So starts at the maximum. Okay, starts at maximum. Travel with me now, then goes down to 0. Yep, goes to 0. Then where does it go after 0? Minimum. Good. Goes to minimum. Min. Totally butchered that one. Then back to 0. And then where does it end? Ends at, so again, don't say 1, ends at maximum. Sine and cosine, this is where we're going to live for the week. And that's what your quiz will be on. Except it'll be moving up, down, left, and right. All right, let's do this. I'm going to make an executive decision here. Number 4, A through D, we'll come back to. I want to graph it right now, though. Let's graph this first. Let's go right to the graph, part E. And then we'll get back to parts A through D, but I want to graph it first. All right, here we go. 1/2 out in front. What's that telling me? Same thing it said for sine. What's the 1/2 telling me now? Instead of 1 and -1, it's only going to go up to 1/2 and down to -1/2. So we're going to have a tiny one here. All right, cosine. If you got to look back in your notes, look back. Where's cosine start? The max, which for us is 1/2. So take a look. It's going to start right at 1/2. Then it goes where? Goes to 0. Again, that's going to be at pi over 2. Every 90 degrees, we graph what's called one of these key values. Max, min, 0. All right, so I got maximum to 0 to where now? To the minimum now. So to the minimum, it's going to be at -1/2. Then travels back to 0. And cosine ends at its maximum, which in this case is 1/2. So just make sure you're graphing 1/2 and not 1 at the min and maxes. And here is this curve. While we're here, can we just answer part F? Where's this, what interval is it decreasing? And remember, when you say decreasing, make sure you give me the x-axis, values on the x-axis. So where's it decreasing here, from what to what? Because there's only one spot I see. 0 all the way to pi, good. And we can always put that in parentheses, 0 to pi. Okay, all right, let's go back. Now let's go to part A, B, C, and D. Oh, new word. Anybody want to let that roll off the tongue? What's the amplitude? Yes, amplitude. All right, so amplitude, that's what the height of the curve is. And I'm going to provide you with your first formula for this unit, how to find the amplitude. Ready? Amplitude is going to be max, make sure I have it right, max minus min over 2. Not too bad. The maximum value minus the minimum value divided by 2. All right, what is your max? Goes up to what? Goes up to 1. This one, remember, we're on this curve, not the cosine curve. 1/2 cosine x. So what's your max? 1/2 minus negative. Make sure it's not 1/2 minus 1/2. It's 1/2 minus negative, the minimum. 1/2 divided by 2. Bless you. So what is my amplitude here? The height of the curve. What's my amplitude? Should be 1/2. And just so you know where this is coming from, hey, take a quick peek here. Quick peek on, don't do this on yours. How that is generated, that number. You take that line that splits the min and max, so this one right here, and then you find the distance from, that's the wrong curve, Carlina. Here you go. You find the line that cuts the min and max in half, and then you find the distance between that and your min or your max. Okay, so that's how that's a distance of 1/2. Okay? Always positive too. Can't be a negative 3 inches, right? Right, always positive. All right, let's roll through these. What's the period? 2 pi. It's always going to be 2 pi for now. Yeah. A couple days that'll change, but for now the period, it always takes 2 pi to do a full curve. What was my max again? 1/2. Good. And my minimum? Negative 1/2. And that leads into part D, which means what's my range? Written correctly too. Range? Surrounded by brackets. Yep. And the last one. Oh, this is where I really get fired up. Here we go. Here's our last one for today. And then you're going to take over. All right, I just want you to graph this piece. What's the only thing that's different that we haven't talked about today? Yeah, what's the deal with the negative out in front? Okay, here's how the negative affects every graph we do. Anytime you go for a max, it's actually a minimum. All the points flip over the x-axis. All right, so any minimum becomes a maximum, any max becomes a min. Any 0 stays 0. It doesn't flip, it stays there. All right, so that is the only thing this negative does, is it flips it over the x-axis. That's it. Minimums become maxes, maxes become minimums. Zeros, you stay right where you are, around the line. All right, buckle up. Sine curve. Everyone start thinking sine curve. Every sine curve starts, for today anyway, starts at, all right? So that's not going to move. Usually it would go where? Usually the sine curve would go from 0 to the max. But now we're flipping it because it's negative out in front. So instead of going to 2, we're going to go to, there it is. Pick up on that pretty quick. Now where's sure to go back to? 0. Usually at this point in the curve, we'd be at a minimum. Nah. Negative says flip it. So we're actually at 2. And then for today, we always end the sine curve at 0. So see how it flipped? Instead of increasing, it decreases first. Okay, so that is the only effect a negative has. Only effect. Okay, you should fly through some of the, all you're doing is graphing sines and cosines. And 1 second here, please. Please don't get freaked out by the last one on the next page. 7/2 is just what is a decimal? Anybody? So if you don't like the fraction, write in 7/2, 3.5 instead. Okay? All right, call me over if you want me to take a look at anything here. Yep.